In this episode, we're going to look at how to set up SonarQube on an Amazon EC2 instance to run static code analysis on a .NET 6 web API. Hey everyone, Wes here with Productive Dev. I hope you're doing well. In this episode, we're going to look at something that I find really fascinating and really useful, and it's something that I don't think really gets covered very often in YouTube videos or in other online formats, and that's looking at the topic of static code analysis, specifically with a piece of open source software that I really enjoy using called SonarQube. So in this video, we're going to look at running static code analysis using SonarQube by running SonarQube on an Amazon EC2 instance. And we're going to look at just how easy it is once SonarQube is deployed to run static code analysis on a very small .NET 6 project that I have set up for this video. So as a bit of a preview, this is a project that we're going to be working on in future videos throughout the month and throughout the year on the channel. As you may have seen in a previous post, I'm also going to be working on a complete rewrite, a cloud-native rewrite of the library management system, which is a video series that was pretty popular that I produced back in 2017. So that project's definitely due for a big update. The project that we're going to be using with SonarQube here is also in this case, a smaller .NET project, but it's something that I think we could use as well to look at some of the new features of .NET 6 and how to actually work with .NET 6 on AWS. In this video though, the main focus is going to be deploying an instance of SonarQube to AWS and then running a static code analysis on this project. So one of the things that I really love about SonarQube is that we can integrate it into continuous integration pipelines and get this continuous feedback on the quality of our code. And what we mean by code quality from a SonarQube perspective really is looking for things that are common smells, like code smells, things which are probably not best practice, things which might have a high cognitive complexity, just typical practices where SonarQube can basically give us some feedback that, hey, maybe some of the code that we've written could really be rewritten to be a little bit higher quality for our fellow developers. In addition to the code smells, it's also going to help us find bugs. For instance, if we're writing methods which can return null values, or SonarQube detects that we have loops which may be either unnecessary or which may not ever properly exit. There are dozens of types of bugs that SonarQube can identify in a C# project. It can also very importantly identify security vulnerabilities that might be sort of these critical types of vulnerabilities that we should look out for. So it can identify things like connection strings and passwords that we may have inadvertently exposed in our source code. Another feature that I really like about SonarQube is that it can give us feedback on the accessibility of the code that we write, specifically when we're talking about UI UX. And so it can analyze HTML files and CSHTML files that you might have as part of a Razor page, and it can identify some of those critical accessibility issues. Along with that, it's really nice in that it can give us examples of non-compliant and compliant code when it does discover these issues in our source code. And so in that sense, SonarQube is also a really great learning resource to kind of get a better understanding of how to improve code quality by example. So in this video, we're going to dive in and we're going to set up an instance of SonarQube on AWS on an Amazon EC2 instance, and we're going to look at how to install a piece of .NET tooling via the .NET CLI to actually execute a sonar scan of our .NET project. And this is going to be really easy to set up. We'll see how we can do it in just about 20 minutes or maybe half an hour. So I hope you enjoy this video. If you get anything out of this, be sure to subscribe to the channel for more work on this project in the future. And as a Patreon of the channel, you also get access to all of the source code that we look at in this and all of the videos on the channel. So thanks for watching. Now let's dive into some code. Okay, so what we're going to do here is we're going to stand up a new EC2 instance where we can host our instance of SonarQube. And this is going to be actually a pretty simple install. We're going to do it directly on a VM. And so let's look at how to stand up a new EC2 instance where we can actually host SonarQube. So I'm at the EC2 dashboard here, and I'm just going to select launch instance. I'm going to scroll down to use, in this case, I'm going to install on Ubuntu 20.04. And for the purposes of the demo, I'm going to stand this up on a medium, a T2 medium size instance. You should be able to, for the purposes of exploring SonarQube, set up a micro instance. I would recommend something with a bit more memory if you plan on using this for production workloads. And in any case, if you are just following along with this video as a demo, then we'll also look together at how to make sure that we actually spin down our VMs in EC2 so that we're not actually running anything and paying for anything that we're not actually using. So at the end of the video, I'll show you how to actually deprovision an EC2 instance and make sure that it's terminated. We'll configure the instance details here. Now, normally I would host this type of infrastructure in a private subnet. You can see other videos on the channel where we look at setting up a VPC where we have public and private subnets, and we host our web applications and other infrastructure in the private subnet that can be accessed through a proxy. In this case, for the sake of simplicity, I'm just going to host this instance for demo purposes in a public subnet and auto-assign a public IP. This is just going to simplify things for the demo. But do know that typically we would want this type of infrastructure hosted in a private subnet and not necessarily directly addressable from the public internet. We would set up some type of proxy where we could control access to it in our private subnet. So for now, we'll leave this in a public subnet and we'll have a public auto-assigned IP address. We can add storage. I'm going to go ahead and bump this up to 12 gigs storage. I won't worry about adding tags, but I am going to set up a new rule. We will allow SSH. You can also allow this just from your IP address. I would recommend hardening down as much as possible. It is best practice here to, say, harden down SSH access to a controlled set of IP addresses. You can use just your own IP address here, and I would recommend doing that for your SSH port. We're going to allow access from anywhere on port 9000. Again, if you'd like to harden this down just to your particular IP address, then you can select that here as well. I'll say anywhere for this case. This is going to be the SonarQube port where SonarQube is exposed, and this is obviously SSH access. So again, be sure to use your own IP addresses here or some controlled set of IP addresses so as not to actually leave these ports open to the world. Again, we'll be accessing over SSH, so you should have an SSH key that's not shared with anyone else. But again, best practice to really harden this down as much as possible. We'll review and launch, and I'm going to go ahead and launch this. If you don't have an SSH key set up, then of course you can generate that here. I do have one set up for the demo. Okay, so our new instance is running. I'm going to call this SonarQube demo. And in a moment here, we'll actually be able to connect to it. You can see the status check is still initializing. When we do want to connect to it, what we'll do is we can select connect here, and you can see there's a convenient SSH command for us. We can go ahead and copy this, and it is accessible on via this DNS here. And in fact, if we go back to the instance itself, we see that it has also been auto-assigned a public IP address. Again, this would not be something, we wouldn't have a public IP address if we were deploying this in a private subnet, as I would do for a sort of fully set up production instance. So let's go ahead and try to connect. And in this case, I think I need to explicitly provide the path to my SSH directory. We'll add the hosts to known hosts on our development machine, and you can see that we're now connected. So we're in the home directory, and we need to do a few things now to actually install SonarQube. First thing I'm going to do is run sudo apt get update. And the next thing that we're going to do is we're going to install the OpenJDK, and so we're going to install OpenJDK 11 here. Okay, so the next thing that we want to do is to install and configure Postgres, and so we're going to use Postgres as a backing database for SonarQube itself. SonarQube can track over time not only users who can be assigned to issues, but it can also track the number of issues that have been resolved over time. And so in order to manage the state, SonarQube integrates with Postgres as one of the database providers. And so I'm going to, essentially here, we're going to add the Postgres repository, and I'll be sure to include the commands that we're running here in the description of the video as well. Now we'll add the Postgres signing key, and with that we can actually finally install Postgres here. Okay, now that Postgres is installed, we're going to use systemctl to enable it. This will make sure that Postgres is running anytime our VM actually restarts. And finally, we can attempt to start Postgres with sudo systemctl start PostgreSQL. If we want to check to make sure it's actually running, we can run status, so we can say sudo systemctl status PostgreSQL. And we can see that Postgres is now indeed running. Let's go ahead and change the default password to Postgres, and we can do that with sudo password Postgres. I'm going to provide a new password for this user. And we'll switch to this user. And be sure to use your new password. With that, we're going to create a new user, which is going to act on behalf of SonarQube, called Sonar, so we can use the command create user sonar for that. So I'm going to go ahead and log into pSQL here. This is going to get us a connection to our Postgres database, and now we can actually alter our Sonar user's password with the command alter user sonar with encrypted password. Provide some strong password, so in my case I'm going to just say some strong password. Be sure to provide something that you can remember here, and that is indeed a secure password. Then we're going to create a SonarQube database and set the owner of that database to our Sonar user. And then we're going to grant that Sonar user all privileges on that database with the command grant all privileges on database SonarQube to Sonar, which is our user. Now we can exit Postgres. You can Control-D or \Q, and we'll exit out to our root user again. Okay, so that's all the basic setup we need in terms of setting up Postgres. Let's actually set up SonarQube now. So the first thing that I'm going to do is install zip if it's not already installed on our machine. Then we're going to download SonarQube using wget from binaries.sonarsource.com/distribution, and we need to find an appropriate version number here. So what I'm going to do is head over to sonarsource.com, and let's find the most recent version of SonarQube that we can download. So at sonarsource.com here, I'm going to scroll all the way down until we find SonarQube, which is probably under their products as well. Yeah, self-managed SonarQube is what we want. Let's scroll down here and find this try it free. Where we get to our downloads, and I see here that version 9.3 we want to download for free here. If I download this, I can see, okay, and so this has started downloading, although I can see that there's a link here, and if I copy the link and paste it into the browser, I can see that the route is binaries.sonarsource.com, distribution SonarQube, and then this long version number here, the really long patch number. Let's go ahead and just paste that in here. And let's make sure that we can get this on our machine. Okay, we have a 404 here. So maybe what I'll do is I'll head back into where it's downloading here on my local machine. I'll go ahead and stop the download. I'm just going to grab the whole link. And so we'll sudo wget and then the whole link here to see what's different. I just had double SonarQube in the description, or the URL. So, okay, so we've downloaded SonarQube now. We can see it in our directory, and now, of course, we need to unzip the zip file. So for that, we can just sudo unzip. Our SonarQube file. This is going to inflate everything into a directory of that name. So we have this long SonarQube name. What we want to do is move this to our opt directory under a more convenient name. So what we'll do is we'll simply move SonarQube here to /opt/SonarQube. And this we need to sudo as well. Okay, so that directory has been moved, and I'm going to remove our zip file now. So now that SonarQube has actually been moved to our opt directory, what I'm going to do is create a dedicated group for the SonarQube user. We don't want the SonarQube application to run as root. In fact, it can't run as root. So what we're going to do is sudo group add sonar, and then we're going to create our Sonar user and add them to our group. So for this, we use sudo user add -d and then /opt/SonarQube -g sonar for our user. Now we're going to give the SonarQube user ownership over that directory with the chown command. So we'll say sudo chown sonar :sonar /opt/SonarQube -r for the entire directory recursively. Okay, so now we need to edit a number of different configuration files to set Sonar up before we can actually run it. This is where it comes in really handy to be able to use a text editor from the terminal, so feel free to use Vim or Nano here. I'm going to use Vim, and we need to edit the main SonarQube configuration file, which is now at /opt/SonarQube conf sonar.properties. And we're going to find the line that says sonar.jdbc.username. We can see that here. We're going to uncomment this along with password. We're going to provide it with our Sonar password and then our username and password for the SQL database. Then we need to find the section for the JDBC URL for Postgres. We're going to uncomment that here, and we're going to get rid of the query string here. So it should read JDBC PostgreSQL //localhost /SonarQube. So now we're done with this file. We can go ahead and save and exit. Now we need to edit our Sonar script file. So we can do that using Vim or Nano again here at /opt/SonarQube bin and then Linux x84 sonar.sh. Here we need to find the run as user directive, and we're going to run as user sonar. So we'll go ahead and save and exit. Okay, finally we're going to set up a new systemd service to manage and run our SonarQube process. So for this I'm going to sudo vim /etc systemd system, and then we're going to create a new file for sonar.service. This is going to be a standard systemd service file. We're going to have a unit with a description called SonarQube service and just have the settings that I have here. It's fairly minimal. When the process starts, we're going to basically invoke the sonar.sh file with the argument start and to stop with the argument stop. We're going to set a limit for the number of open files here to 65,536, and number of processes to 4096. Okay, so if the service file looks like this, you should be good to go. We'll go ahead and quit. And now let's go ahead and enable SonarQube to run at startup. And then finally, we should be able to start our SonarQube service. With that, we can also check the status of SonarQube, and we can see that it's now running. So by setting this up as a systemd service, it's now very useful to be able to start and stop the service and monitor its status using sudo systemctl. Okay, one final piece of setup that we have to do here is really the result of SonarQube using Elasticsearch for a search index. And we just need to make a few modifications to the VM to make sure that everything runs smoothly. So the first thing that we're going to do is edit our sysctl comp file. And so for this, we can sudo vim /etc/sysctl.conf. And we need to add a couple of lines to the bottom of this file. We're going to set the nmap count, the max map count here, to 262.144, and the file system file max value to 65.536. If you don't make this modification, you'll find that when files, as you're running SonarQube, attempt to be indexed, then you will get an error that says the max map count should be at least 262.144. So if for some reason you run into that error and you have not made this modification to your sysctl file, that should also fix that particular error. We're going to go ahead and do that before we get the error in the first place. And so we'll go ahead and quit here after saving that file. All right, now we're going to reload our sysctl file by providing the command sysctl --system. This should work without rebooting. Let's go ahead and sudo that. That should reboot or reload our sysctl directives that we provided here without actually rebooting the system. Let's make sure that SonarQube is still up and running. So here we can sudo systemctl status sonar. We can see that it's running. We should now check to see if the SonarQube web UI is running, and for that we can just try to visit the URL at port 9000 in our browser. So we can head back into EC2. We can see that we have our single running instance here with no alarms. So as far as the VM is concerned, things are looking good from AWS's perspective. Let's go ahead and copy our public IP address, and then we're going to visit port 9000. You can see that when we do this, we should now get a UI, and I'm going to go ahead and put the username and password admin here and log in. That should be the default login. So we'll provide our old password, which is admin, and then we'll provide our new password here, which can be, of course, whatever you like. We'll go ahead and update it. Now, there are ways, and I would definitely recommend doing this. Perhaps I'll make a follow-up video about this, to hook up SonarQube as part of a standard CI, continuous integration pipeline. This can be really convenient. It can make it extremely essentially trivial for developers to get that instant feedback or gradual feedback about code quality as developers make changes to the code base. I'd like to show you in this video just how to set things up manually. So we'll go ahead and create the project manually. We're going to use a project that's sort of in progress here on the channel called Mindful Gifts. And so we're going to call the project name Mindful Gifts. And we'll go ahead and set that up. Again, we can look at how to set up a continuous integration pipeline using Jenkins or GitHub Actions or some other CI platform. But for the purposes of just demonstrating how to do this manually, we can run our project from a local dev environment, and so we're going to set that up here. We'll generate a token. We can really name this anything. I'm just going to call this mindful-gifts. And we'll go ahead and generate this. We need to make sure we copy this token that we've been provided, and then continue. We're going to use .NET, and this is a .NET 6 project. So we need to make sure that .NET Core is selected here. .NET Framework is, of course, a previous version of .NET. And with .NET Core forward, now .NET 6, we can actually add a global tool for SonarQube to the .NET CLI. So let's go to an example project. So I'm here in a solution directory that contains our mindfulgifts.sln file. What I'm going to do first of all is I'm going to run the global tool install command. So .NET tool install -- global .NET Sonar Scanner. So I'm just going to actually copy that, and we'll paste it here. You can see on my machine that this has already been installed. And then there's just a few steps that we need to set up here. First of all, we'll call .NET Sonar Scanner begin, and we'll pass it our mindful gifts key and the host URL, importantly, to be this remote host that's hosted in EC2. The login file here is actually the token. So we can see this 2BF token. That is actually our sort of secure login, if you will. And I think the best way to actually run our Sonar Scanner begin command, as well as the build and end commands, is to use PowerShell if you're on Windows. If you're on a Unix-like environment like Mac OS or an Ubuntu instance on your dev machine, then you shouldn't actually run into this issue. This is just something that I run into on Windows, and I think it has to do with the way that these /k/d inputs to these commands are sort of mangled in different ways. For instance, I know if we were to switch out the /k with a -k, I believe that works, but -d doesn't work. And so, long story short, I just found it easier to use PowerShell if you're following along with the commands provided by SonarQube. So here I need to go back to our projects directory. And in PowerShell, the ls command is dir. And so we're in the root of our project directory where our SLN file is, and we're just going to copy this first command for Sonar Scanner begin. And we'll go ahead and run. This will take just a second. After this, we will run .NET build, which will actually build out our binaries. And then we're going to run .NET Sonar Scanner end. This is going to publish our results and essentially analyze them on our remote instance. So you can see this step will actually take the longest. For even a very large .NET project, this analysis, I should say the analysis really will vary by the size of the project. For an extremely small project like this, it'll be done in a matter of seconds. And I would say for just as a point of reference, on an example project that I have that is around 500,000 lines of code, the SonarQube analysis doesn't take longer than 20 to 30 minutes on even a small, relatively small VM. And so just as a point of reference, this isn't something that will typically take hours for medium-sized projects to run. And in our case, for a very small project like this, it's going to take really just a minute or so. Okay, so once that's done, and I should say that this took maybe 2 minutes or so on my machine for this really small project, you can see that the analysis itself only took about 8 seconds, and we get this output that the execution was successful. I can see here that it was actually about 3 minutes and 15 seconds, and it will let us know that the Sonar Scanner CLI has finished. If we head back into SonarQube, which is hosted on EC2, we can go to our projects directory here, and we can see that we have an analysis of our simple project. Now, the project here is sort of a trivial size. This is just something that we've just started for work on presenting different demos on the channel here. Nonetheless, we can see we have a couple of bugs, bringing our reliability rating down to a C here. Luckily, we don't have any known vulnerabilities. We do have a security hotspot to review. And you can see that it even gives us an estimate on the amount of time it will take to basically pay down our technical debt. Maintainability is good though, so that's a good sign, and we've got a number of code smells to address. Okay, so if we want to just kind of take a look around at SonarQube on a small project like this, again, it's not going to be incredibly interesting yet. We will revisit SonarQube on the larger cloud-native library management system, as well as on this Mindful Gifts application throughout the year on the channel as we develop it. But we can see very interesting graphs that relate sort of code coverage to technical debt. Later, we'll look at publishing our code coverage results, which can be exported to formats that SonarQube can ingest and then actually interpret to look at how many lines of code are covered by unit tests. But it's useful here to have sort of a general overview. We can see an enumerated list of issues that we would take care of here. We can see we've got a number of issues that we would want to take care of here. You can see that SonarQube will catch a variety of issues, from things that are sort of code smells, things that maybe aren't necessarily best practice. It can find actual accessibility issues using like WCAG 2, and it can find a number of known vulnerabilities and practices related to exposing things like connection strings and other configuration that might be sensitive. It's really good at finding these things. It's also good at measuring cognitive complexity for finding like methods which might have too many branches in them to really be easily understood and interpretable. Another nice thing is that if, say, you're unfamiliar with a type of smell or a type of a code smell, a type of bug that SonarQube is calling out here, what's really useful is you can select this, why is this an issue? And SonarQube will do a great job at typically showing you a non-compliant code example as well as a compliant code example. So if you're unfamiliar with really how to fix the problem, SonarQube actually does just a fantastic job providing you with examples so that you can kind of reference how you might actually go about solving the issue in your own code. You can see that it often goes into a great bit of detail for us, which I find to be really invaluable, particularly for an open source free tool like this. We also note that we can configure different rules. There are many different rule sets for different languages, including C#, but as well as JavaScript and TypeScript, PHP, Python. You can see the list here. And we can configure our own quality gates. So if we want if we want to say like we need to maintain a certain amount of quality through any number of different metrics, like lines of code coverage or number of security vulnerabilities, which might be 0, things of that nature, we can set up our own custom quality gates that are relevant for the particular team and the code base that we're working on. We can see different quality profiles here. An administration panel, which has a lot of different options. One of the nice things is that we can also set up users in SonarQube, and then as users, we can log into SonarQube with our own logins and actually take ownership of different issues that we might have. So if I say, I want to basically own this issue, we can select ourselves here as the administrator owning this issue. And all of this data in this state is persisted so that the next time we log in, we can actually see the issues that we're owning and then, of course, address them. And when we run a subsequent scan, we'll also be able to see hopefully the quality of our code go up as we see the technical debt go down. So that's it really for a simple intro on how to host SonarQube in AWS on EC2. What I'm going to go ahead and do now is actually spin down the VM that SonarQube is running. This way we're not paying for anything that we're not using. Again, if you were using this in a production-like environment, this would be a resource that would be a long-running resource. And in the future, we'll look at how to actually integrate this type of resource into a CI pipeline, probably through both GitHub Actions and Azure DevOps. So let's go ahead and terminate our existing EC2 instance. So I'm back here at the EC2 dashboard, and we're going to select our SonarQube demo, and I'm simply going to change the instance state using terminate, and we'll say terminate. This will now shut down our instance. SonarQube itself will no longer be accessible. For instance, if we try to open it back up again on this port, on port 80 or port 9000 or any port whatsoever, it's no longer accessible as the instance is now being terminated. So that is, I suppose, it. Stay tuned in future videos for where we look at integrating SonarQube into a CI/CD pipeline and actually automate some of the process that we looked at here, making it really easy to collaborate on quality among our teams. So thanks for watching, and I'll see you next time.